it?
Yes. Oh.
You look terrible.
I don't care. This is all your fault! Oh, how can I stay mad at you? Oh.
All right.
All right.
Hello and welcome everybody to another episode of
The Super Data Brothers Super Show.
That's right. I'm Ryan.
I'm Eric.
And we are real life brothers who work in the data and analytics industry. And have we got a good one for you today, folks?
Boy, do we. You know, I'm so excited for today's show, Ryan, because we have our special guest today who we'll be talking to in a minute, Matt Housley, co-author of Fundamentals of Data Engineering, you know, which is a big book we've talked about a lot on this show. And I think it should be a really interesting chat with Matt. So, and anyone who's wondering why we didn't have an intro video, it's because I'm away from my house. I'm not at my tower, so I couldn't make the intro video. So I just played a Simpsons clip. So
that's right.
I hope you enjoyed.
Yeah, I hope you enjoyed. All right, so it's great to be back. We took a kind of a 6-week hiatus for the holidays and to kind of recoup our energies for data and everything. And it's awesome to be here. For those of you who maybe haven't joined us before, this is a live show, folks. And what that means is that when you put comments in the chat, it fills us with amazing data energy and gives us something cool to talk about with Matt. So get those comments into the chat, folks, those reactions. We will read them live. If there's something you would like Matt Housley to discuss, we will bring it up. And then last thing to discuss before we get started, of course, meet the Super Data Brothers. Our conference calendar is starting to fill up for 2024. Some of them we can't announce yet, but others we can. So where can you meet one or both of us? I will be at IBM Tech Exchange in Barcelona the week of January 22nd. I am doing a presentation on January 24th, moderating a data mesh panel with Jean-Georges Pierre and Scott Herleman. So that should be really exciting. And then, of course, Data Day Texas, our absolute favorite conference here in North America. We love Data Day Texas. Matt will be there. Lots of other people who you fly. I guess I'm saying Matt will be there. I don't know that for sure. We'll ask Matt when he comes on, but I know lots of other people will be there. So please join us there. Eric, can you flash the discount code on the screen? We have a discount code for y'all.
Was it just...
Yeah. There we go. Super Data Brothers, all one word. I think that gets you 20% off your registration. So do check it out. And then I will be at the Gartner Data and Analytics Summit, May 13th through 15th in London. So if you're in the UK and you're going to the conference, it'd be great to say hello. Maybe we'll do some sort of super data meetup or something associated with that conference too. So we can meet up in a pub or something like that. So I think that's all we have for intro today. Why don't we go ahead and bring Matt onto the show and get started here.
All right.
All right. Great to see you guys. Thanks for the invitation today. This is going to be a lot of fun, I think.
Yeah, happy to have you.
And
absolutely.
I will be at Data Day Texas, incidentally, so I'm really looking forward to this one. Last year was my first year, and I just had a lot of fun. I mean, the talks are going to be great, but especially the networking and just connecting with everyone, all these thought leaders in the industry is going to be fantastic. And I don't know how I assume attendance this year will be more because it was last year was kind of the post-COVID reboot. Yeah. So I'll have to ask Lynn how things are looking right now.
Yeah. I think they're going to be good. And like it is. If you go to the conference website and just look at the list of speakers, I mean, it is like a who's who of the people who I personally want to talk to in the data industry. So it's just an awesome event. We had a blast there last year. So cool. All right. So welcome to the show. Congratulations on co-writing like the biggest data book, I think, in ages. It seems like it's been
since
a huge
Bill Inman
success.
wrote one.
That's what I aspired to as a kid. I'm like, someday I'm going to write the biggest data book of 2023.
Yeah.
Is that what we all aspired to? Like, how did you end up in this situation of being the Super Data Brothers?
It's the same thing. They asked me as a child, what do you want to do? At first I said astronaut, and then I said, I want to be a small-time data influencer on LinkedIn. And so here I am.
Yeah, and I wanted to be a small-time data influencer's brother who does a show with him. That was my goal.
I see we have
He doesn't
Lindsay
post on
Murphy
LinkedIn very
in the
often.
chat. Lindsay will also be at Day to Day. Lindsay, glad to see you tuning in here. So, I think to kick things off, Matt, I'm kind of curious. So you know, fundamentals of data engineering. It's obviously been a big success for you and your co-author Joe. I'm kind of curious. We have a lot of data engineers in our audience. Our audience also includes a lot of downstream people from data engineering, a lot of BI people in particular. And so, if you could just kind of give us an overview of the history of data engineering, kind of as you experienced it. How did you get to the point where you felt, hey, I'm someone who could write a book on this topic?
Yeah, that's an interesting question. So I arrived in the data industry like fairly late, to be frank, because I was an academic. And so I had a PhD in math. I taught math for about a decade. And then one of my friends kind of recruited me to get into data science. And then I ended up drifting into the data engineering side of things because the problems we needed to solve to actually deliver what I'll call product were data engineering problems. Like we could do the data science aspects, but the productionization of data was what was causing us trouble. And so I kind of saw several generations of data happening simultaneously when I got into the industry. So first of all, I worked with Teradata quite a bit. And if you're not familiar with Teradata, it was kind of the first MPP system. It came out in the 70s, right around the time that Oracle was really starting to push the relational concept. And so, in fact, the first versions of Teradata weren't even really relational, as I understand it, or at least weren't SQL based. And then they adopted that technology pretty quickly. And then they became kind of the early, back then, they weren't using the term big data, but like that was sort of one of the first big data systems. By the time I got into things, it was starting to feel pretty archaic. And then if you remember a couple of years ago, how much do you both remember about Hadoop? Like, were you right in the middle of the Hadoop era? Okay.
No, I was in the Hadoop era for sure.
Yeah. I think I joined like right as people were realizing like, oh, this Hadoop thing's not working for me.
Yeah. So when I got into it, Hadoop was like still the cool kid on the block. And so everyone talked about how if you were serious about data, you're going to be writing your own MapReduce jobs. And in fact, there was this assumption that like if you were a serious data scientist, you probably needed to write MapReduce jobs. And maybe you needed to use some terrible programming language like Java. No, sorry, just kidding. but Pig, one of these languages that's like very low level string parsing, getting deep into the raw data, having to manage your own schemas if you even bothered with that. And there were interesting results that I saw derived from Hadoop, but just the overhead involved was so astounding. And there was overhead at many levels. So you had the just basic programming overhead. You had the optimization overhead. In other words, if the jobs weren't written well, they would run extremely slowly. Exploratory analytics was a huge headache because at least in our system, like the time to return a result could be 5 minutes, 10 minutes sometimes if you were doing anything remotely interesting. And there was the security overhead was a big one. A lot of the reason our system was slow is because you had a very poor, like not performant way of checking security for individual blocks of data. And that obviously has to be done. Like security has to come first. And so this back end would just slow everything down almost to a halt when you were trying to do anything interesting. And then right around that time, there was this tech called Spark that had come out and was starting to get a lot of traction, and people were very excited about Spark. And then also, I started to hear a lot of rumblings back then about Redshift, and then maybe a year or two later about Snowflake. And I didn't know too much about what those technologies actually were, but as I started to make that transition from pure data science to data engineering that supports data science, I got involved in a couple of different cloud trials. So we were basically exploring new tool sets that would take us into AWS or GCP. And so I was able to spend a lot of time with those tools fairly early and say, okay, for most of what we're doing, using like a Snowflake or a Redshift is actually going to be far, far more efficient. Yes, SQL is a limited language, but it's also fast to program compared to most other languages that you're looking at. And that if you need to do something that's highly custom in terms of data processing, then Spark starts to look very interesting because it's to me, Spark is a language that's really, really nice for the cloud because it's expensive to run on-prem. It's the classic, like, why do you lease an aircraft rather than buying it? Well, just so much capital involved. Same thing with memory. If you want to buy enough memory to run Spark, it's very, very expensive. But suddenly on AWS, you just borrow it for 2 hours, run a really cool job, and then shut it down. And so that was kind of my experience going all the way from the early days of on-prem MPPs to Hadoop to cloud, and not only cloud, but like the fully managed cloud services that made a lot of the tasks of data engineering much, much easier. And so as I was going through that, I started to realize, okay, there are a lot of areas of data engineering where it is important to get into the details. But as a data engineer, you really want to focus on that when it's a special competency. And then if it's not a special competency, if it's just something that's fairly off the shelf, then let someone else worry about those details so that you can focus on the stuff you're good at. I think back in the era when I got into tech, there was maybe a failure to recognize the sheer cost of labor in Silicon Valley, in tech companies, and even in non-tech companies. And that's where a lot of the obsession with Hadoop came from. So I talked to one engineer who was at Google in the early days of MapReduce, and I think he said they were using C++ to program MapReduce jobs, which just sounds like complete insanity. Like the amount of drudgery to do anything like that, like string parsing in C++, the amount of labor required to do that. Like, yeah, I guess if your job is scaling up to, costing millions of dollars a year, maybe that optimization makes sense. But in practice, delivering data value faster by just getting the job out the door quickly at a low cost and evolving it and iterating quickly is much more valuable to data engineers. And so there was this natural evolution from like really low level internally at Google to like very, very abstract, which is the type of data engineering that we have now. And so I think what allowed Joe and I to write the book, partially we were successful in this because we didn't work on the guts of Hadoop. We were able to survey the domain a bit more because we could look at it from the perspective of assembling pieces as opposed to having to be working, close to the CPU on these really big systems and focus on one tiny piece. I think our perspective is that most data engineers now are a little bit closer to architects. Like, yes, it's not a pure architecture job, but your goal really is to assemble all these pieces. Yeah. Did that answer your question? Sorry, that was a very long-winded answer.
No, that was exactly okay. that was awesome. And so I'm curious, so then when does you and Joe are doing this professionally, and then when does the idea hey, maybe we should write a book about this thing occur to you guys? What's the story there? And then what was the overall writing process like?
So I think originally someone approached Joe about, I think it was Pact approached Joe about doing a book. And so once that concept was on our radar, we started shopping it around a bit, and he invited me to join him, which I'm very grateful for. It was great to be his co-author in spite of the intensity of that co-author relationship. And so we eventually decided that in terms of support resources, in terms of timeline, in terms of quality product, O'Reilly was going to make a lot more sense for us. And so we talked to Jess Haberman, who's an acquisitions editor, and she started mapping out the process. And it turns out that on the one hand, O'Reilly was very excited about this concept of having a book about data engineering in general, as opposed to a book on a specific technology. So O'Reilly is kind of the backbone of, I would say, of tech content even now, in spite of the fact that we have a lot more content channels than we did, say, a decade ago. And they had published many, many books about, for example, Hadoop, about Pig, about Spark, about all these technologies in detail. But I think they realized that, first of all, the market was evolving toward more abstraction. And second, they needed a book that kind of tied all those pieces together, that said, all right, you can read these individual books to understand specific technologies, specific programming languages, but how do you decide even which technology to use? How do you decide where to put these technologies into a pipeline? And so they were excited about that concept on the one hand. On the other hand, they were also kind of scared of it. And Jess told us that. She's like, you shouldn't do this. This is crazy. It's too ambitious. It's too big. And so that's why when you said a big book, it's like 400 pages long, which is kind of ridiculous, right? It's like a ridiculously long book in terms of number of pages. But we working with her, we were able to conceptualize it, and we really had to be careful to limit the scope to make the book actually work. You can't like write about the details of Spark programming if you want to have a book that covers the whole domain and that really covers architecture and stitching technologies together. On the other hand, you do want to get into some of the engineering considerations, things like latency and disk types and network bandwidth, that engineers are going to have to think about in order to optimize their jobs and in order to choose technologies and so on.
Was that a challenging thing, like finding the right level of kind of abstraction versus, what, we are going to go deep on this particular technical topic?
Yeah, it definitely was. And we ended up writing some material that got cut down the line just because it did end up being, say, too technology specific. And I think that's just part of the book writing process. On the one hand, you need to have a solid outline, but then you need to keep generating ideas. And some of those ideas really do need to end up on the cutting room floor, right?
Yeah.
So if you go to YouTube, there are all these videos about how various movies were really created in the edit. In other words, you look at the early footage and there's a lot of footage that's just kind of junk. And to make it good storytelling, like you need to go through that creative process to create the good stuff and the junk and then edit it down into something good. And so, yeah, that's ultimately what we had to do to get that level, like try a few things and then eventually dial in on where it ended up in the final product.
Yeah. One of my favorite sayings is, perfection is achieved not when there is nothing left to add, but when there is nothing left to take away. Right. And that's something I live by, even when I'm doing technical work. Oftentimes that's what, if I'm building a dashboard, that's part of what I focus on, is like, how can I get it to where I've removed everything extraneous from this, and all I have left is the truly useful stuff.
Which, in my experience, ends up being I create a dashboard, and then what I end up with is like a table, a table with
yeah.
And just the last column has what the percent they were looking for, and that's really what it ends up being. So,
yeah. I mean, the Simpsons clip is shockingly relevant. Like, how did you end up creating that kind of Simpsons clip meme, or how did that come about? Because like that certainly resonates.
Yeah, I've been watching. Been doing this show. I did this more at the beginning because I was more gung ho, but been watching like random Simpson clips on YouTube because YouTube just suggests Simpson clips to me. So I'm like, okay, how can I turn this into a video for the show? Then so there's the dashboard. We've got some other ones we can play later if you want to see them. But.
Yeah.
Oh, fantastic! Yeah. We'll throw in some filler here.
Yeah, we have a library of data related Simpson clips that we occasionally bust out here.
Yeah, let me pipe in here real quick. Just a reminder to anyone watching that we are live. So if you want to leave a comment, we will discuss it. I know we have a pretty good turnout today. So if you want to leave a comment, we'll talk about it. If you want to just shout out where you're from, we'll give you a shout out at some point. So just a reminder, this is live and interactive. So you have any questions or any bones you need to pick or controversial opinions, we will discuss it if you leave a comment. So
yep, absolutely. Okay, so now it's going through the story of the book. So now it comes out. At what point did you realize that you had a hit on your hands?
I think we started seeing a bit of traction fairly early. So O'Reilly has this pre-release process where even as you're drafting material, when it gets to a certain point, they'll take it and start publishing it, and they'll get it into the proper format. It's still messy. There are still typos, grammatical errors, all the stuff that you end up with in the book writing and editing process. Frankly, that stuff still exists in the final book, but hopefully not too much. But they just send it out there. And we started to see some traction where people were actually looking at it fairly early, which was really cool. And then as the pre-order came out on Amazon, as we were getting close to our delivery date, to our publication date, we started to see some traction there. And then once it was published, I think that was June 2022, fairly quickly, within a few months, we just saw a big ramp up in sales, which was great. Like when you write a book, you don't expect to actually make any money off of it. It's not an income, but it's a nice supplement to other things. Let's say that.
Yeah.
So we saw that ramping up. I'm like, oh, a lot of people are actually buying this book. I wonder if this is sustainable. And then on Amazon, we started seeing that, we were number one in, say, data mining or desktop databases, or all these different categories. And then we would see like an 8,000 or sometimes 5,000 or sometimes lower rank in the all books in Amazon. So that was really cool. Like you don't expect to get that kind of ranking writing a very specific tech book that has an extremely narrow audience, frankly, right? Like it's by the standards of the tech industry, the audience is pretty big because it is broad. But the tech industry is a tiny slice of the world, which we often forget when we operate in this industry. So yeah, it was very, very cool to see this. And it's continued to hold up. It's continued to sell, which has created a lot of conversations and opportunities. I think for me, that's been the most exciting thing. It's just it opens the door to talk to so many people and have conversations like this one.
Yeah. Yeah. And what now I mean, you and Joe are kind of data celebrities at this point. What has that, what was that like? How did that transition feel? And like, is it, um, I know when you're at a conference, you get random strangers coming up to you and talking to you about the book. Like, what has that been like? Is that kind of a surreal experience or?
Yeah, it's a little bit surreal. I think I'm naturally kind of an introvert, and so it's very strange to have so many people talking to me, frankly. Like, okay, so I taught, college I taught university math for a decade, like I said, and so I'm used to being up in front of people, but usually you go up and it still feels kind of anonymous, right? All the students come in the room, they sort of sneak in because their homework is late or something, and they're trying to keep their heads down, and then occasionally
you just
they'll
call
ask
him professor instead of your name.
Yeah, exactly. That's right. And then they show up to office hours once in a while. And so it's very strange to like go to these conferences and have so many people know who you are.
Yeah.
Definitely surreal. I haven't fully adapted to this, I think.
Yeah, I can imagine. So we do have a question from Govindarian. I apologize if I butchered that name, but do you think data mesh adoption will increase among organizations over time now that many vendors are providing some native features to implement a data mesh?
Yeah, that's a good question. So I want to kind of divide this topic into two parts, really. So I think there's data mesh, the organizational philosophy, and there's also the technology that you need to actually implement data mesh in practice. And of course, as a company, if you have enough resources, you could potentially build the technology yourself, right? But we know how that goes in data. Like companies just don't have the resources to worry about that. They barely have the resources to build the dashboards and analytics that they actually want, especially if they're not a tech company. So in terms of the organizational part, I think we are seeing more of that over time where organizations are coming to see that this is a good approach to data, that the traditional core team, data warehouse that handles all the data and everyone kind of sends requests into that team is a limited model and that there are other ways to attack the problem. And for the technology part, I think we are seeing improvements there where data sharing is getting simple enough that it's practical to implement this, that the technical challenges, the security issues you have to deal with are not too terribly overwhelming. Maybe we can follow up this question later. I have some thoughts on the startup space and just generally what's happening with data companies right now that is related to that are related to what he's asking about here.
Yeah, I mean, I think yeah, I am curious, like, when it comes to the adoption of data mesh too, and we'll get to that, the startup space. I mean, that's kind of my next prepared question for you, so
Yeah.
it's coming. But
Okay.
I am kind of curious, like, when it comes to data mesh adoption too. This is an area, like, I recently saw a post by kind of an analyst who I respect a lot, and
Yeah.
data mesh was one of his topics that he thinks is like dying out, and I'm curious, if you see, like, is the concept of a data mesh, is that going to stick together, do you think? And are we still going to be talking about a data mesh, in 5 years? Or is this one of those ideas that is going to be very influential, but as a coherent concept will fade away?
That is a good question, huh? It's hard for me to commit one way or the other on that, but I think at least it's going to be influential enough to cause a permanent organizational evolution. Whether or not the ultimate organizational structure that becomes very standard is exactly the data mesh, I can't say. But I think, again, we are moving away from the monolithic team structure. And I think there's both the influence of the book on data mesh, which mapping out these ideas was like a huge service to the community and great thought leadership by Zhamak Tagani. But there's also just the technology aspect. And I think a lot of the reason we didn't have data mesh in the past was that the database situation looked kind of like the old in mainframe days. I guess we lost Eric. Okay.
Yep.
But you had, you would have like a Teradata system just sitting in the basement, and someone was responsible for babysitting that. And whatever team babysat the Teradata system also tended to handle all the analytics and all the data coming in. And I think now that that data is becoming very pay as you go, and you can slice it thin, and you can share data between verticals easily. I think that technology aspect is changing the organizational structure in parallel with these organizational ideas. And so I guess in general, to summarize, we are moving toward an era where things are less centralized, and that part I think is here to stay.
Yeah. I really agree. And I think it's been very interesting to see which parts of the data mesh concept have the most legs. I think it almost feels to me like so many organizations read that book and then what they did is said, well, the data products part we feel like we can do right away. So we're going to do that. And then these other parts, like, we'll try to do those over time, but let's just start with bringing product thinking into data. And I feel like if nothing else, the way that data mesh has accelerated product thinking in data has been a huge service to the community.
Yeah, at MSU, that's how that's kind of like, because getting like convincing a large organization, being like, okay, HR department, you're in charge of all your data now. We're just gonna like query it with an API like that. Ask me that in 10 years and maybe we'll do it. But like, just like data product, like a data team internally can start data product thinking and like spread it to the organization. It's like an easy sell. I've seen it be an easy sell internally at my organization, like that aspect of it. Yeah.
Yeah, it's funny when APIs became very, very standard in the early 2000s. You saw this idea floating around, and you still see it around. Like somehow, if you have an API, everything is going to be super, super easy, and data exchange is going to be really simple. Anyone who's actually dealt with building API connectors knows that this is not true at all. That's why entire product companies have been built just to access data that is stored in APIs. And so that's where I think we need more standardized tooling. We need things like Snowflake data sharing or BigQuery data sharing or Iceberg, where data is simply exchanged in a standard format. And yes, you have schema. Yes, you have descriptions of data, but you're not trying to deal with some custom API. You're not moving 1,000 rows at a time. The data is just there in a storage system. You can access it. And I think that is that was the key challenge in the early days. After the book came out, people would say, oh, well, just use Spark for this, or just use this tool. And it's like the simpler you can make it, the better, because these product teams are developers. They're not data experts, and they have a lot of other stuff to do. And so like make it the simplest possible tool that lets them share their data. And then this concept can work.
Yeah. So let's talk a little bit about the state of the industry in general, right? And some of the trends, that we saw over 2023 and kind of where you might see things going heading forward. And maybe, we could probably, there's a million ways to slice this, but you kind of mentioned you have some thoughts on what's happening at the startup level. So let's kind of start there. Like, what do you see going on at startup in the data industry right now?
Yeah, so I think I mean, you were both around for this. You had a previous wave of data companies, and you had things like Google BigQuery. That wasn't a separate company; it was a major product. You had Snowflake, which is probably the flagship product in the space right now. You have Spark, you have Databricks. And so that wave of companies was up and coming. And then the Snowflake IPO happened, and COVID happened right around the same time. And when the Snowflake IPO happened, it triggered this new wave of interest in data. Like all the venture capitalists said, hey, that is amazing. Like, look how much that company is worth.
Yeah.
We need to get into data too. And the consequence of that is that it was great to inject so much capital into this core data space. When I say core data space, I'm excluding things like AI and large language models for the moment, but like these core data tools. Tons of money was injected, just outrageous valuations. And so now we're seeing the backlash from that. And venture capitalists are pulling back their capital. In many cases, you're seeing companies just shut down. And my theory on this is that the VCs come to these companies, the founders, and say, look, it's going to be extremely hard for you to ever meet the valuation target that we reached because we're preferred shareholders. You're probably not going to make much money off of this. And we would really like our money back so we can put it into generative AI companies, honestly. Yep. And so, it's going to be good for you if we just shut this down. We'll help you find the next opportunity if you play nice with us. And so I think that's what we're seeing right now. And I think we've seen a lot of big startup shutdowns in 2023. I think there will be more shutdowns and acquisitions in 2024. But I think the flip side of that is that anyone who can survive in the space is probably going to do really well. Most of the companies are going to get acquired. They're going to merge. Some are going to shut down. But the ones that survive are going to do extremely well going forward. Going back to generative AI, I don't think that's just hype, but I don't think the fact that generative AI is really big right now is going to remove the need for really good data tools. In fact, the opposite, right? Like at some point, there will be another wave of another phase of startups where we realize, oh, we have all these great generative AI tools, companies that we've been investing in. Now we've let the tool space languish, and that will be the next wave of companies in our domain that comes up. I think if you are a data engineer and you have a really good idea for a tool right now, if you can bootstrap, if you can build a company that's lean, and if you can survive for a couple of years, there are probably really big opportunities a few years going forward, especially if you can feed into all the tools around generative AI. So like basic text processing capabilities, for example, data quality will always be a really big need across corporate America, but also I think increasingly we'll be talking about data quality for training models because that has been frankly a huge problem, right? So there's kind of a negative aspect and a positive aspect of data quality. You improve data quality and you get better answers. If you have bad data quality, you do things like inject private data into models. You create hate speech, you create racist ideation, like all these things that we really, really don't want. So if you as a data engineer can build tools that will help to solve those problems, that's going to be really, really interesting. And again, you can target both the I don't think traditional analytics are going away by any means, and this new phase of model training, which is only going to get bigger over time.
It really, it feels to me, at least in kind of where I have sat in the industry, that, data governance and quality really went out of style for a little while. And just it was all about speed, like time to insight. Yes. And, how quickly can I enable a data analyst sitting in the office of finance to be able to answer questions that are coming down from the CFO? And that's very important. But, when Gen AI really hit, it just poured cold water on that whole thing, because suddenly it was like, oh, like this is not going to work based on our existing data infrastructure and all of that. Zenkai Kid, yes, of course you can ask questions, right? This is a live show. That's why we do it live. Is because we want to ask questions. So
thanks for tuning. I think you've asked questions on the show before, so thanks for tuning again.
Yes, this is a repeat viewer here. Welcome back. So that's really interesting. There's also the whole the concept of the modern data stack, and we're going to have you on your own will assemble what you consider the best in breed stack out of point solutions. It's an interesting idea. I think it requires a huge amount of technical skill to really pull off that. I don't, Eric and I live in Michigan, right? The tech skills we have in the Detroit area are much more about building cars and robots and much less about building data pipelines. And so, it's always been something that I see a company like General Motors is just going to struggle to adopt, right? Because they're not going to be able to build this complex end-to-end stack out of 15-point solutions. Do you see just in that world, or I would say like when we were both at Coalesce, it felt like half the sponsors were data catalogs, right? And so do you see just a lot of, is that really when you talk about like, is that specifically the world you see we're going to see consolidation and players dropping out?
I think so. I think there's going to be a lot of stack simplification going forward, both through acquisitions and frankly shutdowns of some companies. And we're also seeing a lot of open source companies building full platforms. In other words, where they originally were focused on one tool, they're now starting to offer other open source tools within the platform. And it's kind of funny. There's a company called Qubel that at one point was a competitor to Databricks that was already doing this, but they just kind of got there a little bit too early, and then they got bought by private equity, and now I don't think they're doing too much these days. But I think the next generation of those platform companies that will probably come out of some of these point solution companies as they expand, that's going to get really interesting. So Snowflake is obviously going to be a big player in this space, but we'll see some others emerge as well. I think there are various tiers of data engineering, right? You have all the way from Google, where a data engineer may just worry about one type of disk system, and that's their entire job, because Google is a massive company with a huge cloud presence. They need to be in the guts of everything. And then you'll have another tier that assembles complex stacks from a variety of tools because they have specialized needs. And then to your point, Ryan, most Fortune 500 companies are not going to want to be in this business. They want to be data companies in the sense that they're really good at using data. General Motors will want to be very good at using data from their vehicles, data from the assembly line, data about quality issues to track down specific parts that are bad efficiently without spending a lot of money, deliver quality vehicles. But they will not want to be building the modern data stack. And so someone who can provide them a fairly simple solution that lets them focus on the data itself and not on the tooling is going to win that race. Yeah.
Yeah. So I don't know what it was about our last call for questions, but suddenly everybody is chiming in.
I think Zen opened the floodgates. So yeah, we've got a lot of questions queued up. So I'll just start bringing up and going through them. Reminder, if you're watching, that we stream most Thursdays, and if you like this, you can like, subscribe, all that stuff, and stream on YouTube and LinkedIn. It looks like you're streaming to Twitch, Ryan.
Yeah, we're streaming to Twitch today too. First time ever.
Yep. So on LinkedIn, I think you're streaming on just look up Ryan Dolly or Eric Dolly, and you can follow either one of us, and you'll see updates from us. So
yep,
let's get going here. Here's a LinkedIn user. Can't see who the LinkedIn user is because of the StreamYard integration, but thank you for the question. Yeah, how do you see hallucinations affecting generative AI? Yeah, in generative AI affecting data quality.
This is Jim Johnston. Thanks for the question, Jim.
I actually want to break this. I'm going to expand the question slightly. So I want to talk both about hallucinations and just general bad outputs that might be based on real data. So hallucinations, the model just makes stuff up stochastically, and it makes things up very convincingly, similar to what humans do when they're either lying or even have brain damage. Like if you have certain types of cognitive impairments, you can still like speak, but you just make things up as you go along because your language system is working, but you're not anchored into truth anymore. And that's exactly what these systems are doing in some cases. And then, yeah, the other aspect is just like spitting out horrible garbage that we don't want people seeing. And then maybe we add a third one, which is, putting out copyrighted material. I think data quality is going to be key to solving two of these. So we kind of make the same mistakes over and over and over again in the data industry. In the Hadoop era, we collected all this data with no regard to quality or privacy or anything else. And eventually we had to slam the door on that and say, you have to think about data quality, you have to think about schemas, and you have to think about privacy when data is collected. You can't just have a free-for-all. And now we're going to have to do the same thing with generative AI models, where we carefully filter the inputs that train that models. We're going to have to figure out how to deal with copyrighted material, with hate speech, with all manner of awfulness, just with misinformation that these models can integrate. In terms of the hallucination aspect, even if you have good inputs, the models are still capable of making things up, just like humans are. And my suspicion is that we'll never fully be able to solve this just by training transformer models. I think what we'll have to do is have a two-layer solution where you have the generating part and you have a checking part that says, hey, is this output valid? Is this output anchored in reality? Is this output hate speech? Is it anything else? Before those responses go out. There's also this interesting work going on using knowledge graphs to basically seed models so that they have something to work with. So for example, in the legal domain, you go search a bunch of legal cases using a legal database system, you feed that into the generative model, and then it runs off of that data rather than just trying to answer your question straight off of the prompt.
Yeah, you know what? One thing at Good Data that we're doing, because we're kind of lucky in this sense that we built a BI tool that has as its foundational element a semantic model, and then and then these LLMs came out, and so the way we're approaching that is like we've separated that. We have the semantic model, and then we just have we use ChatGPT to interact with our semantic model, but it's not interacting directly with your data, right? It's going and saying, you ask it a question, it translates that into a semantic request to our semantic model, which then generates the SQL to go to your database. And we found that that's helped a lot with these issues.
Yeah.
Next question here. Any recommendation, and this one is from Saul M on LinkedIn. Any recommendations for learning to maintain complex DAGs?
Oh boy, that's a tricky one. I mean, I feel like some of this, so in terms of developing basic skills and initial exposure, one nice thing is that it's much, much easier now than it was, say, 7 years ago, to just spin up Airflow or spin up Dagster into cloud environment and get a lot of experience with it. I think in terms of learning long-term maintenance, at some point you have to get into the job space. There's no substitute for professional experience. And getting, paged in the middle of the night when mission critical data doesn't show up. That's just, at some point you have to be in the trenches doing it. But I think the way you get into the trenches is by experimenting hands-on with the tools before you even get that first job. I don't know. What are your thoughts? Because this is, I think this is true of any area in data. You can only do so much on your own before you need to be in a high pressure environment doing this stuff.
Yeah. I think that's true. Like there are great resources out there, the Super Data Brothers show, for example, but, but there's some element of like, you just have to do it.
Just have to do it
in order to get good at it. And, that was definitely like my first job, what was it? 14 years ago now in BI. I truly knew I got hired because the interviewer thought I had a nice personality.
Yeah.
I didn't know.
My first job out of college was doing like analytics and BI consulting. So that was like okay, sure, I'm the expert on this.
Yeah.
And as a consequence, you got a lot better at it. So like,
yep, that's right.
You can only learn so much on your own, but like, don't sell yourself short. What I always tell myself and other people is it's not your job to disqualify you, right? It's the person who wants the project done's job. So if they think just you're good enough to try it, then you're good enough to try it. So don't let that stop you.
Right.
Yeah, exactly. You have to have enough confidence, and someone has to have enough confidence in you for you to start working initially if you're actually going to get good. If no one will give you a chance because you have no experience, then we would have no professional data practitioners. That's where we would be.
Yeah. And I think that that leads into Zenkai Kid's question, which, he's been looking at AI and his great interest in analytics engineering and DBT. And so I think the question is, can someone get into data engineering? He uses the word fresher. I'm going to translate that to noob, from in the current market, maybe from a different career. Like how would you go about doing that? Taking those first steps to become a data engineer?
Yeah, I think you want to read the classics. You want to read things like Bill Inman's book, for example. You want to read about data modeling. The real advantage that potential data practitioners have coming into the industry right now is, again, you can just log in and try these tools without even spending that much money and start experimenting with SQL directly on interesting data sets. I mean, for either of you, were you ever able to play with production type data systems before you got a job?
I mean, back in 2010, that was a lot harder.
It was much harder. Yeah.
No, like not. I basically had an internship at like a BI consulting firm, and that was like there would have been no other way for me to access those tools at that point besides getting that internship. So that's a lot different now, though. Like,
yeah, it's a very dramatic change. And so if I were a young person just getting started in the industry, I would really try to take advantage of that. Jump in, learn these tools, try a lot of different tools. You'll often hear advice like, oh, if you want to be a data engineer, you need to go learn all about Spark, or you need to learn all about Snowflake, or you need to learn all about pandas. And the truth is that at least when you're getting started, you want to learn a lot of different tools. You're not going to become an expert until you really get into a job where you choose a tool stack. I feel like if you just focus on one or two tools, you're going to make yourself too narrow. But like, try a lot of tools, but also learn data fundamentals. Learn what keys are and what joins are and what basic data models are, and kind of go from there.
Yeah, I mean, that's, I think, helped a lot. What helped me a lot is, I had taken a database course where I had to hand break tables into third normal form and that sort of thing. And so I just knowing the fundamentals, and I would also say, there's how to move data from point A to point B.
Yeah.
But then there's like the why and the how to structure it on the end, right? And I think that's an area where I think as a young person, you might have an opportunity to stand out if you do read Bill Inman's book, if you, learn how to talk the talk in the industry and learn about.
What's the title of in case someone doesn't know who Bill Inman is? Like, what is the title of the book we're talking about? Like, do you remember the title of the book he wrote about, like, database?
What is
it? Like, data warehouses?
Building the data warehouse, I think. Let me make sure I'm getting that exactly correct.
Yeah.
Yeah, this is a good point, because I think he's written like 70 books or something.
Right. Yeah. Read the Bill Inman book.
Yeah, from Bill Inman. Like, I'm sure he released one too, like, that last year. Like, he's prolific.
Yeah, Building the Data Warehouse is the classic. But yeah, there are many good books in there. Yeah. Maybe start with that one and then kind of expand out from there.
Maybe check out Fundamentals of Data Engineering. I heard that.
Yes.
That heard that one's okay. I don't know.
Yeah. And if you're just tuning in, that's the book that Matt co-wrote. So
yeah.
It's okay, I guess. Yeah. No. Hopefully you find it valuable. I really appreciate people reading it and getting value out of it. I think that's
And I think as a young person too, the last point I would make on this, I mean, there is, as lame as LinkedIn can be sometimes, there is actually a really rich data conversation happening there. And you can learn a lot about current topics and how to talk about them by just interacting with other professionals.
At the very least, you'll know, like, what words to say to sound like you've got your finger on the pulse, right?
Right.
That'll sound good when you're talking to someone about it, like during an interview or something. So
yeah, exactly. That's hopefully reading our book, you'll at least get a really good overview that you can put other pieces into, and you can talk intelligently about the current state of data engineering in the world.
So I have this question from Kamal. Welcome, Kamal. So how can you measure and present ROI for data engineering projects?
So from my perspective, this is an extremely tough problem, and it kind of has to come. You need leadership that understands the value of data and that gives you some targets to reach for, basically. So for example, let's talk about one scenario. If your company doesn't have, say you're some kind of a product company, say you're a retailer, and you don't have a good vision, you don't have a clear view of your inventory, you don't have a clear view of what's on store shelves, you don't have a clear view of what's in your warehouses. Say you have a data stack, but the data quality is very poor. Well, what that means is that you won't order well. You won't make good decisions about what's selling and what's not selling, what you need to re-up on and what you don't need to buy, which means that you're going to have, after Black Friday, after the holiday season, there are a lot of opportunities that you will miss. There are products that customers want that you won't have enough of, and you'll also be overstocked on a lot of other products. And so having a better data stack, having better data quality helps the people ordering products to make better decisions, which potentially can be worth significant amounts of money to that company. In fact, that if your primary focus is on retail, you buy things, you sell things, it may be the difference between having a profitable year and having a loss-making year. And so just that one aspect of the data stack can have a huge impact on business value. But it's hard for you as a single data practitioner to really sell that. I think the idea is to talk to people who actually are setting the priorities for the business, understand how they use data, understand the limitations of how they're using data and the data they're getting, and then focus on how to actually deliver better data and what value that will deliver to them. So I think it all comes down to really talking to stakeholders. I'm skeptical of this idea that you can really have a P&L for a data team, to be quite honest. I think it's an interesting idea, but I think in practice, the profit impact of a single data team can be much larger than the cost of the team itself or anything that they see directly. On the other hand, there are a lot of data teams doing work that's not relevant, that doesn't connect with stakeholders, that doesn't connect with the core business mission of the company, that are just costing a lot of money. And so I think it really comes down to stakeholder alignment, to both understanding stakeholder needs and also educating them about the possibilities of what you can do with data.
Great. Eric asks, given the complexity of our tooling ecosystem, what tips or methodologies do you recommend for choosing the right tool for the job?
So I'll plug our book again and say that we have a whole chapter on like choosing appropriate tools, basically. But I think there are a couple of common mistakes that we see over and over again. So one common mistake is the idea that you're trying to build something really cool and complex. And this happens at a lot of startups, right? We're a startup, a bunch of our employees came from Stanford or Berkeley. We're all really smart. Therefore, let's build the most complex data stack we can with the coolest tools, with the latest open source, with, bleeding edge releases. And in general, that ends up costing a lot of time and therefore money, because that, employee salaries are very expensive and you're pulling people away from other priorities they could be focused on. And often you end up with just an unmanageable, unwieldy stack that just becomes like compounding tech debt over time and really slows the company down. And that is not good, right? Because at that point, it's not so much just that your data isn't working well, it's that you're undermining the core business purpose of that company. And so when you're starting out, when you're small, when you have a small team, build the simplest stack possible with the simplest tools possible to get the job done, and learn from your stakeholders what they actually need. As you get larger, as you have a larger team and you need data faster in greater volumes, then you can look at diversifying that stack. And that's where we talk about like choosing various levels of complexity. Do you want a Snowflake where it's moderately complicated, or do you need to get into, say, Spark because you actually really need to do something highly custom with data that SQL isn't going to deliver for you?
Awesome. Okay. It's a big topic. How do you think Gen AI is going to change data engineering in the coming years?
That is a good question. I'm still trying to wrap my head around what Gen AI is going to do for coding. So I actually had a New Year's Eve party. This is the kind of cool stuff we talk about when we're drinking, preparing to celebrate the new year. I was talking to one of my friends, and they have a big code base that I think was in C#, and they wanted to translate a lot of it into Python. And this is like a huge labor-intensive process. And so they had engineers working on this, and then they were authorized to use an internal generative AI tool that doesn't train on the data, that protects internal company private data, for example. And they tried feeding in some of this code and having Gen AI translate it. And they basically said that for small code projects, in other words, things where you don't have, millions of lines of code in different libraries, it worked extremely well. It's not that it got 100% right the first time, but it mostly translated it correctly. And then they were able to go in and test the code, find limitations, fix the problems. So it appears that Gen AI is going to be a huge labor saver in anything involving coding. And I've heard similar things when you apply it to SQL, when you generate SQL with it. Again, you have to be careful and you have to check the SQL and you have to correct some errors. But it seems to have a capability that will do quite a bit to augment humans. And so I think that means in practice that, team sizes are going to get smaller, or conversely, we should expect higher output for teams if we learn to appropriately use these tools. I think at this point, we're pretty far from them replacing people fully, but they certainly can make us much more productive if we use them appropriately.
Yeah, that's what I see too. I mean, it's the coding, their ability to speed up the coding process is really significant. It's very interesting, kind of at the front end. I'm very interested to see what people like what different BI tools are able to do, it feels like everything right now is just focused on how can we build a chatbot that enables quicker access to the features of our tool that already exist, which is interesting, right? But I'm kind of waiting for to see what comes after that. Like
the use case we haven't thought of yet.
Yes.
Right.
Yes.
Well, and I'm skeptical of I think we need to be very careful about putting Gen AI into consumer-facing products because it's still dangerous, right? There's still a lot of stuff that can go wrong by doing that. Whereas with engineers, these are people who have access to very, very powerful tools who can frankly tank your whole company by like shutting down accesses or changing an IP address. And so ideally they understand the level of responsibility that comes with using such tools. And they recognize that Gen AI is a powerful tool with limitations and recognize those boundaries and the need to carefully check their work.
Yeah. All right, we're coming up on the top of the hour here. A couple more questions, and then we're going to have to wrap it up. Thank you, everybody, for attending. Great turnout today. Great questions. We broadcast every Thursday at this time, mostly live, occasionally pre-recorded, so tune in next week for sure. Now, this is a two-parter from Colby Wright. So, what should a college student look for in an internship? And then the second part of it, how useful is software engineering background for data engineering?
Yeah, so in terms of internships, I think from my perspective, getting broad experience is the ideal thing, right? Like getting exposed to a lot of different ideas and a lot of different possibilities. So not only are you learning about the profession, but you're learning about what parts of the profession you might actually find interesting. I don't know. What are your thoughts? What have you seen in this domain? I know I had a few interns that worked under me at various jobs in the past, and I think just getting that exposure was very valuable for them as they continued on in college, as they went to get jobs or as they went to graduate school.
Yeah, I agree. I mean, having a broader, I was talking to Ben Stansel about this, and he said something very interesting to me, which I'd never considered, which was kind of like, as a young person, you should try lots of things career-wise, and you should be on the lookout for someone who maybe does something professionally, someone older than you who does something professionally that you have interest in, who also appears to really love what they do. You should be searching for that person. And when you find them, you try to get to know them and figure out what their path was like as maybe a potential path for you. And the only way you're going to do that is by sampling, getting a broad experience, because you first need to figure out, do I like coding or do I not like coding, right? Am I more, is the infrastructure interesting to me or is it not interesting at all? And only by knowing that can you then kind of search for that, that person who you can maybe develop some sort of mentor-mentee relationship with, or at very least learn, okay, what did they do? Because they're 45 and seem to have a great career, and I'd like to be there someday. So, you won't be able to replicate their path because things will change, but there'll be things you can learn there. And I just had never thought of that approach before. I thought it was very interesting.
Yeah, I think that's totally right. I mean, fundamentally, developing a good career is a matter of social capital. Obviously, skills matter a lot, but you just want to get exposed to a lot of possibilities. And I think in many cases, you may end up in a career that you didn't anticipate at all. You may start training to do software engineering, and you may end up doing product. I mean, I am operating in a domain that I wasn't planning to go into when I was getting a PhD in math. And I think that happens to quite a few of us. And so having a lot of conversations with people who seem excited about their careers, understanding why they're excited and why you might or might not be excited about that career is just invaluable. It's like steering your decisions more even than just learning specific skills, like learning where you need to focus as you build your career out.
Yeah, absolutely. I mean, I studied playwriting, so
yeah,
you don't know where things are going to take you.
That is absolutely true.
Okay, last question. I will simplify this as SQL versus Python. Fight.
Okay, so I don't view this as a fight. I view SQL as a baseline skill that every data engineer should have. And in the Hadoop era, we were very dismissive towards SQL, saying SQL is dead. No one's going to be using SQL in a few years. And then tools like Hive and Spark SQL came out, and we acknowledged, oh yeah, no matter what framework you're using, you probably want to be able to use SQL because it's this very simple set theoretic language that's very powerful, that's fast to code, and so on. So learn SQL as a baseline skill. I just expect it of any data engineer. Even a new person in the industry should be able to have a solid grasp on SQL. Then learn Python to stand out, because I also want to see very solid Python skills, but I view that as a more advanced skill than SQL. So learn those baselines, then learn Python, learn specific frameworks, learn things like PySpark, Airflow, Dagster, Prefect, all these different frameworks that you might expect to interact with as a data engineer. And then you're going to be an exceptional candidate if you have not only Python skills, but Python skills in a variety of interesting frameworks that your employer might be deploying and that where they might have a shortage of skills.
Yeah, I think we got a lot of questions from young people trying to enter the field today, which is really exciting. I think my number one piece of advice is like, try not to sweat too much about this sort of thing, right? Like getting the foundational skills in place, developing competency with SQL and Python, and learning, the basics on how to orchestrate data flows and that sort of thing, right? But don't get too hung up on, which specific, I have to be an expert in X, Y, or Z tool, and that's going to be my path into the industry. It's you're not, first of all, as we discussed earlier, you're not going to be able to do that. You're not going to be able to become an expert in these things until you're actually tasked with doing it for real. So first of all, there's that. And then it's just, that's not, I've hired many young people over the years. That's not what we're looking for,
Right.
It's just like, we're looking for enthusiasm, ability to learn, right? Some degree of apparent passion for the job, culture fit. That's what you want out of a young person entering the field.
So if you like have no idea what to do, and that's people ask these questions like, well, what should I learn? Because they're just starting and they don't know what to do. It's like, well, like, I don't know, take our advice that we just gave right here. And then think of a personal project you want to do that will involve a database so you can write SQL, and Python so you can move data somewhere or do some advanced calculations. Think of a personal project and do that. And if you're like, internship questions come up, like during an internship interview, like if you bring up, oh yeah, I worked on this, this specific thing that like I was really into. It's like, it doesn't really matter what it was. Just the fact that you're super interested in it, like, is like a person trying to break in. That'll look good during one of those interviews, like as an entry level interview.
Yeah, I mean, the truth is a lot of the same advice applies for experienced people. So, for example, maybe you have 15 years of Hadoop experience because you got into it at the very beginning, and then you were the person who babysat that stack as it kind of matured. And if I'm hiring an experienced person, I'm actually pretty excited about that Hadoop experience because I know that that person knows a lot about data. At the same time, I'm probably not hiring them to run Hadoop. So I want to see enthusiasm, willingness to learn, willingness to kind of pivot the skills that they have into something new. So now can they take that and get really good at Spark or get really good at Snowflake or whatever it is I need them to do for the company?
Yeah, that's a good point. It's just good advice no matter where you are in your career. Yeah. All right. So Matt, thank you so much for coming on the show. It was really fun to have you. And where can people, if they don't know, where can they find you?
I think mostly LinkedIn these days, and then the Monday Morning Data Chat, which is also a live show that runs on LinkedIn. So normally that is at 11 Eastern on Mondays. I think we had a slight time shift this time, and it will be on at 10 a.m. Eastern this coming Monday, if I'm not mistaken, just because our guest needed us to adjust the schedule a little bit. But yeah, Monday Morning Data Chat is great. And then a variety of conferences, places like Data Day Texas, where I will see you, Ryan. Eric, are you going to be there as well?
Yeah, I'll be there as well.
Fantastic. Okay, I'll look forward to seeing you.
Yeah, and if you do want to meet the Super Data Brothers and Matt and his co-author Joe Reese and dozens of other data influencers who you may follow on LinkedIn, we're all at Data Day Texas. So check it out. It's a one-day conference in Austin. It is a super good time. really valuable presentations. I would say this is the most no BS data conference that I attend. And I really enjoy it every year. So check it out. Code Super Data Brothers will get you a discount on your registration. It's coming up in just a couple weeks, so you're going to want to register now. Awesome. Well, Matt, thanks again for coming on the show. And if this was your first time watching us, every Thursday at 12 o'clock Eastern time, we
most
broadcast. Most Thursdays, yeah. We took a break for the holidays, but we're back. 12 o'clock Eastern time. Tune in. And until next time, I am Ryan. And this is Eric. There we go. And we are the Super Data Brothers. Take care,
Thank
everybody.
you. Now, as a sign off clip, here's another Simpsons clip.
Oh yeah, we promised more Simpsons. Here you go.
This is what happens when a user submits a ticket.
Hi, Larry. I'm sorry, it's just that on the school bus. May I have that seat?
Yes, if you can answer me these questions 3. Question the first.
Never mind. Excuse me, sir.
Don't make me tap the sign.
But I'm lost and I need to know where.
1 eternity later.
All right. Thanks,
there you
everyone.
have it.
Bye.
We've all been there. Great hanging out with you guys. Thanks for the invitation.
Yeah, thanks, Matt.
everyone.
Take care.